Hello and welcome to Learning Economics. Let's continue our journey of learning data analysis with R, and today we are going to discuss about two very important features that we will be using. First, we shall be talking about the pipe function. Pipe function basically helps us working more effectively and efficiently, saving a lot of our time. It takes the information from left hand side argument and feeds it as an input to the right hand side argument. We shall practice it in a little while and things will become more clear and easier for you. The other important package that we shall try to study today is Dplyr, which is also a part of tidyverse. And as you know, the tidyverse is a large package that hosts many of packages in its side, as we have already used one of its package, which is ggplot2 for data visualization. The Dplyr package helps us in analyzing the data and exploring various aspects of it. So let's practice both the Dplyr package as well as pipe function using R Studio. So let's come on the screen. So let's first bring the tidyverse to the library. And as you already know, if you have already installed tidyverse, you do not need to reinstall it. But if you have not, then you need to install this package. I have covered the process of installing package in my previous videos. So if you have not watched those, I would recommend you to watch this series from the very first lecture. So let's bring the tidyverse to our library. Library tidyverse. It's taking a while. Now you can see the Dplyr package is there, forecast, ggplot2, and other many packages are there. Similarly, like this, we also need to bring in the data set to our library as well. This time we will be using New York flights data. So let's bring this data to our library as well. NYC flights 13. Yeah. Okay, let's have a view of this data. View, and we can just write it short name, that's flights. So here it is. You can see the year, months, day, DEP underscore time, that is departure time, then scheduled departure time. Actual, this is DEP underscore time is actual departure time. And then this is scheduled departure time when it was supposed to depart. And this is the delay in the departure time, which is the difference between scheduled and actual departure time. Similarly, arrival time, scheduled arrival time, and arrival delay, carrier, flight number, and other. So let's have a look at the structure of this data. str is the structure command, structure flights, and you can see that there are some integers, some numbers, some characters, and some date time variables. What is the difference between these two? Let's discuss this difference first before moving on to analyzing our data. So an integer is basically a numeric data in which you can see the numbers 1, 2, 3, or maybe the numbers in points, but these are usually positive numbers. Whereas NUM number or double, DBL, double, this is for the real numbers, and you know the real numbers are the whole numbers as well as numbers in points as well as positive and negative. CHR is for character, and characters are actually the string variables. That is, these are the variables which are normally alphabetic in nature. So if you have the name of the candidates who are appearing in the interview, you have a list of those names. That variable will be a character variable. And lastly, there is DTTM or date time variable. You can see it's is appearing POSIXCD. So this is again basically the nature. It tells us that the nature of this variable is date, years, months, time. So time like variable. So these are different kind of the variables that we usually have in our data. And as we will proceed, we will talk more about each of these types of the variable. On the other hand, the actions that can be performed using dplyr function, actions or the verbs are organized into four groups based on what they operate on. These are rows, columns, groups, and tables. However, in today's video, we shall work only on rows and next will be covered in the upcoming videos. So let's get back to the R Studio screen. The first verb of the dplyr that we are going to study is filter. Filter, as its name suggests, it only keeps those rows based on the value of any column entry. So the first argument is the data frame on which you are working on, whereas the next argument is the condition that must be true to keep these rows. The conditions can be defined using greater than equal to, less than or equal to, and not equal to criteria. So let's work on this. So we have the data. If we want to filter this data and get information about only those flights which are late by more than 2 hours. So how can we do that? We can use filter, and then first argument will be the data. So our data is flights, and the next is the condition. So we want only those flights for which the departure delay is more than 2 hours, and 2 hours mean 120 minutes. So sorry, FILTER filter. So here you can see there are first 10 rows of the data that confine to this condition, and it is displaying only 10 rows and telling us that there are 9,713 more rows to this variable. So this is how we can work on using the filter. However, we can also do the same thing using the pipe function, as we will write flights, use the pipe function symbol, and then give our criteria, filter DEP underscore delay greater than 120. Now what it is doing, it is taking information from the first argument, that is flights, feeding it as an input into the next argument, which is filter. So again, we have the same result, same 10 rows and same 9,713 more rows to it. We can also combine conditions using and or condition to indicate and. That is, if we want any two conditions to hold at the same time, we will use and symbol. And for or means either of these two conditions met should be displayed, then we use or, this symbol, to indicate or. For example, let's go to the previous command. We say the filter depart delay is more than 120 and minutes, that is more than 2 hours, and we want only those flights that departed with on the first date of any month. So we will combine these two conditions, that is day that is equal to 1. I already told in one of my previous videos that if you want to use a criteria of equal to based on the information from within the dataset, you need to use 2 times equal to sign. But if you want to give these conditions from outside, that is, this information is not in the data, but I just want it to impose this condition, then you need to write it first time. But this is a common mistake. You will learn the difference between double equal to mark and single equal to mark with your practice and by making mistakes and then learning from those mistakes. So let's just see it. Now you have all those flights in which the depart delay is more than 120 minutes. This, and the flight is on the 1st of any month. So it is the 1st of January, and there are 378 more, 10 of which are being displayed. In this way, you can combine multiple conditions using AND function. For example, if I also want the flights, only those flights that arrived late as well. So I will write arrive underscore delay, and this should be greater than 0. So all those flights which departed delay by 2 hours, they arrived delay as well. So delay must be any number greater than 0 and were scheduled on the first date of any month. So all these conditions should be met. And now it is stating that these rows in which all the conditions are meeting, and it is saying that 10 rows are here and 375 more rows are there in the data. Now, how to use OR condition? Or, I mean, we just go to the previous. I'm saying either the flight departure time is delayed by, let's say, 3 hours or 180 minutes, or it is scheduled in January. Or means any of these conditions. If or means I need only those flights in which any of these two conditions met. So either delay by more than 3 hours, fine, or it should be in January, fine, or both, then also fine. So these in which either the departure time is more than 3 hours, or it is scheduled in the January, and it is saying that there are 30,686 more rows to this data. Now let's talk about the other verb, which is arrange. As the name suggests, arrange is used to rearrange the data based on the value of the selected variable. For example, if I use flights and I'm using the pipe function and using arrange by depart underscore delay. Oh, sorry, I just used the wrong symbol here. It must be this. So now if you go into the data and depart delay from the lowest value -43, -33, 30, and all the values are arranged irrespective of the month, irrespective of the date, irrespective of the time, but they are arranged based on departure delay. This arrangement style, as you know, is called as arranging in ascending order. The values are arranged from the lowest to the highest. But if you want to arrange them in descending order, that is from the highest to the lowest, you need to define that, or you need to put that I want it in the descending order. So for that, you just need to write descending, that is D, sorry, DESC over here, and Sorry, again the spelling mistake. Now, just look at Dplyr, the highest value followed by the lower, 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 lower. So all these are arranged in descending order. This is how you can use this range verb. But one more example which will help us understand how pipe function makes our job much easier as well as much efficient, and how we can use both the filter as well as arrange together. So we will be using another data which is tooth growth data. Again, this data set is also pre-uploaded in that, so we do not need to re-upload this data. Just let's view this data first. So let's say view, it's with the small t and small g, and as I told you earlier, R is case sensitive, so let's wait it to be displayed. So only three variables: len, SUPP supplement, DUSC dose, how much dose is given, so supplement is VC, dose is varying, and supplement also OG, dose is varying. So these are the two supplements. Dose and lens value is also varying. So let's assume that we want to filter only those observations for which the dose is 0.5, and then we want to arrange them as per the value of lens. So without using pipe, if we need to do it, we will do it like that. We will first create another uh, data set which we call as filtered underscore tg tooth group. For example, you can give it any name. So I will be using filter, and filter is followed by data set, and the criteria is dose is equal to 0.5. It has created this. Let's have a view of it. View and filtered underscore tg. So now filtered underscore tg, all those values for which dose value is 0.5 only. Now we want to arrange it as per lens value. So we can use range, the data set filtered underscore tg, and the criteria which is lens value. Now you can see over here all these values 4.2, 5.2, 5.8 in increasing order of length. All those values are arranged. However, we can do all this using pipe function more efficiently. So let's try doing that using pipe function. This time I am giving the name tg1 to this new variable, or tg11 rather. So this I want to use the data of grade and want to use this data as input and filter it as per dose which is equal to 0.5, and then want to use this filtered information as input to arrange it according to length, value of length. So what it is doing effectively, it is taking this information, that is tooth growth dataset, as an input to this filter function. And once this filter function is applied, using its output as an input, applying the arrange function. And once this is all is done, this is creating a variable named as filtered underscore tg11. And if you view this variable filtered underscore tg11, it will exactly be the same but very well arranged: 4.2, 5.2, 5.8. So the results are exactly the same as we see earlier. For example, the 13th value is 11.2, 14th value is also 11.2, then you can see 15th value 11.15, The 18th value is 16.5. Here it is also 16.5. So all that. So in this way, the pi function makes our life much easier, makes our work more efficient. Now let's learn our final verb of today's lecture from the Dplyr package, which is distinct. Distinct actually finds all the unique rows in the data set. So for example, if I want that flight data, and let me see if yes, that is all here in the library. I want to see all the unique origins. Just let's have a look. So yes, all the unique origin and destinations. So distinct as per origin and destination. Oh, sorry. I again made mistake in the spelling. Distinct, Distinct, distinct. So now it is just giving all those flights in which the origin and destination are some unique values. That is, those values are not uh, repeating as much as the other values are repeating in the data set. Now, towards the end of this lecture, I want to give you an exercise and want you to think about these and do some practice how you are going to solve these questions. So first, find all those flights that had an arrival date of 2 or more hours. What function you are going to use? You are going to use filter. And with what condition? Greater than or equal to 120. Next, all the flights that flew from Houston, if Houston's code is IAH or HOU. So what we are going to do? We are going to apply the filter function with OR condition because there are two codes. So any of the code matching will work for us. And next is all those flights that departed in summer. That is, they departed either in July or August or September. So July is 7th month, August is 8th month, and September is 9th month. So we will again use the filter function with OR condition. Last question is that which flights traveled farthest distance? Now we need to use the arrange function and we need to use it in descending order so that the first value will be the value where the distance value is the highest, and that value will answer our question. With this, we are ending this lecture today and we'll come back with more functions and more useful things that will help us analyze the data using R. Please do give a thumbs up to this video, subscribe to this channel, and share these videos among your friends and fellows. Thank you and goodbye.